Welcome to 6.2 Solving Trigonometric Equations Part 1. We're going to look at example 2. Solve the equation cosine theta cotangent theta equals negative cosine theta over the interval 0 degrees to 360 degrees. So we first need to decide if it's linear or quadratic in form. Since we have two different trig functions multiplying together, this is going to be quadratic in form. So we need to set the equation equal to 0 and try and factor. I will add cosine theta to both sides. Cosine theta times cotangent theta plus cosine theta equals 0. Now we need to try to factor this. We have two terms, and each of those two terms has a cosine theta in it. So we will factor out the cosine theta. From the first term, we're left with a cotangent theta. For the second term, we factor everything out, but we need a +1 as a placeholder so that we maintain two terms. And this still equals 0. Once we set it equal to 0 and factor, we get to the stage where we have a times b equals 0. You might pause and ask yourselves, what can you say about a or b if a times b equals 0? The answer is a has to equal 0 or b has to equal 0, or they both could be 0. Therefore, these two quantities multiplying to 0, one of them must equal 0. So either cosine theta must equal 0 or cotangent theta plus 1 must equal 0. The cosine theta is already isolated in the left, but on the right we need to isolate the cotangent theta. So we subtract 1 from both sides. We get cotangent theta equals -1. Now let's look at each of these. On our unit circle, where is cosine theta equal to 0? Anytime we have sines and cosines equaling ±1 or 0, we're expecting a quadrantal. So we have to figure out which quadrantals give us the x value is 0. That's going to be here and here on the y-axis because we have the coordinates 0, 1 or 0, -1. So in degrees, our theta is either 90 degrees or 270 degrees. Now let's look at cotangent theta equals -1. First, we might notice that cotangent and therefore tangent are negative in quadrants 2 and 4. When we have cotangent of theta equaling ±1 or tangent of theta equaling ±1, our reference angles are going to be 45 degrees. And that's because cotangent is x over y, and the only way to get ±1 is if the number part of x and y are the same, and 45-degree angles have the x and y equal. So we have two answers here. In quadrant 2, we notice that here is 180 degrees, so we have to subtract 45 degrees from 180 degrees to get 135 degrees. In quadrant 4, we are 45 degrees less than 360 degrees, so we have to subtract 360 degrees minus 45 degrees to get 315 degrees. Therefore, putting our answer all together, we have 4 angles that satisfy this equation. We get 90 degrees and 270 degrees in addition to 135 degrees and 315 degrees. So all 4 angles are solutions to our equation. Practice. Solve sine x times tangent x equals sine x over the interval 0 to 2 pi. Again, because we have two trigonometric functions multiplying by each other, it's quadratic in form, so we need to set it equal to 0. I will subtract sine x from both sides. Now, sine x tangent x is all one term, So it's not the same as sine x by itself. So we just write sine x tangent x minus sine x equals 0. Notice the signs cannot cancel because sine x is multiplied by tangent x, so subtraction will not cancel it. Now we factor out the sine x because both terms have a sine x in them. So the first term leaves us tangent x, and we need the minus 1 as a placeholder, so we maintain two terms. Now that we have factored, when it's set equal to 0, we could say each piece equals 0. So either sine x must equal 0 or tangent x minus 1 equals 0. We'll solve the one on the right by adding 1 to both sides, so we get tangent x equals 1. Now let's solve sine x equals 0. Again, because we have a sine or a cosine equaling plus or minus 1 or 0, we're expecting a quadrantal. Now, sine x equaling 0 corresponds to our y values being 0. So that's going to be on our x-axis. Because our coordinates are 1, 0 and negative 1, 0. Our y values are 0 in both of those. In terms of radians, this angle right here is 0. And this angle right here is going to give us pi. Now, tangent of x equals 1. Tangent is positive in quadrants 1 and 3. And when we get tangent or cotangent equaling plus or minus 1, our reference angle is going to be 45 degrees or pi over 4. So in the first quadrant, our x value is pi over 4, but we have to do some work for the third quadrant. Here, this angle is pi, but we have to pass pi, so we have to calculate what is pi plus pi over 4. Well, we could write pi as 4 pi over 4, so we get 5 pi over 4. So we end up getting 4 answers to our original equation. From the sine x equals 0, we got 0 and pi, and from our tangent x equals 1, we got pi over 4 and 5 pi over 4. Oftentimes, the solutions will be written in increasing order. So 0, pi over 4, pi, and 5 pi over 4 is also another way to write the solutions. But both of these answers are acceptable because these are not ordered pairs. They are just a list. So the order is not actually crucial. One thing I want you to notice is that oftentimes, once you get down to a trig function equaling a number, we often get 2 solutions per picture. Not always. Our quadrantals sometimes only give us 1 solution, but oftentimes we get 2 solutions. I hope you enjoyed the video. See you next time.